All right, class. So in 6.2b, we're going to learn how to apply the Pythagorean theorem to find missing side lengths. Now in 6.2a, we learn that the Pythagorean theorem only applies for right triangles, meaning a triangle that has a 90-degree angle. Now, before we start applying this and finding missing side lengths, we need to know important features of a right triangle. Now, if you notice, here's my right triangle, here's my right angle, and anything that is adjacent from the right angle, meaning right next to it, coming from the right angle, is called your legs. So that means here's my 90-degree angle. This side length is called a leg. And then this one right here is also called a leg. So these are the legs of your right triangle. Now, A and B could be interchangeable here. So you could label this as A and B, or you can switch it around. This could also be A and that could be B. So with practice, you're gonna understand why. However, what's across the right angle, so this right here, is called your hypotenuse. Okay, and that's usually labeled C. So what the Pythagorean theorem states is that if you take one of your legs squared, take your other leg, square it, it will equal to your hypotenuse squared. So that's the famous formula, okay? And we're going to apply that. Now, before we start applying that, we have to be able to identify whether you're finding a leg or hypotenuse, okay? So in the Desmos lesson, that's what you're going to work on. So all you need to know or identify is whether the x variable in your right triangle represents a leg or hypotenuse. Okay, so what I want you to do right now is pause the video. I believe there's 4 or 5 problems, and then play the video, and then I'll go over it, okay? So pause it right now. Okay, so here we go. Notice here's the right angle. So that means what's adjacent are your legs here. So 9 and 12 are considered your legs. That means x, which is right across from your right angle, is considered your hypotenuse. Okay, so moving on. Next, here's my right angle. So everything adjacent from my right angle are considered my legs. So that means the x is considered a leg. Moving on. Here's my right angle. The 7, side length 7, side length 3 are adjacent to the right angle. And what's across from it is your hypotenuse. So that means x is your hypotenuse. The x variable here represents, well, let's locate my right angle, which is right here. Anything adjacent to it, right next to it, is considered a leg. So 6, and the variable x is considered a leg. Okay, and that means the 10 represents your hypotenuse. Okay, look for the right angle. Anything adjacent right next to it is considered a leg, so that means the side length 10, side length 24 is a leg, and what's across from it is your x variable, and whatever's across from the right angle is because it's considered your hypotenuse. Okay, so you should have stopped here. Now let's apply it. All right, so I'm gonna work on a few problems. I'm not gonna do all of them. I'm going to do number 1, number 3, number 7, number 8. Okay. And then for the other problems, I would want you to check online. Either Mr. Goddard or I will post those notes on Google Classroom so you can check your work. Okay. So in number 1, I'm going to find the missing side length C. Now, if you notice, here's my right angle, and here's my leg. And my leg. So that means I'm finding the length of the hypotenuse. So here we go. So I have, this is a leg, A, and this is the other leg, B. So it doesn't matter how I label it. This could also be B and A. They're just both legs. what really matters is you identify the hypotenuse. That's what really matters, okay? So a squared plus b squared equals c squared. So we're going to use the Pythagorean theorem to figure out the side length, this hypotenuse. What's the measurement of that? Okay, so a is 9, and I have to square it. B is 12, and I have to square that to find what c squared is. Okay, so 9 times 9, 9 squared is 81, plus 12 times 12 is 144 equals c squared. So I'm going to add those numbers up. 81 plus 144 is 225. Now, I still have to solve for c. So if you remember in the previous lessons, so inverse operation. So the inverse operation of addition is subtraction. The inverse operation of multiplication is division. So the inverse operation of squaring something is taking the square root of something. So taking the square root is the inverse operation of squaring something. So they cancel each other out. So whatever I do on one side, I need to do on the other side. And the square root of 225 is 15. And the square root of c squared, they cancel each other out. They're the inverse operations of each other, so that you're just left with c. So that means in a right triangle that has a side length leg of 9, a side length leg of 12, that means the length of the hypotenuse would be 15. And I use the Pythagorean theorem to figure that out. Okay, so I would want you to work on number 2, but I'm going to type in for number 1, 15. So number 2, I won't go over. That will be in the notes, so you can check your work there. Problem number 3, I will go over number 3. Okay, so here we have a missing side length, but if you notice, here's my right angle, here's my leg, which is right there, and here's the other leg. So in this situation, now we're finding the missing side leg because they're giving me the hypotenuse. Okay, so let's use the Pythagorean theorem here. I have a squared plus b squared equals c squared. So they identified this as a leg, labeled it as b. Here, this would be my a, and my hypotenuse would be my c. Okay, so let's just plug them in. Let's substitute these values here. A is 24, so 24 squared, plus b squared. That's what I'm trying to find. What is b? And then c squared, 25 squared. Okay, so you might need a calculator. It's okay to use your calculator. I provided it on Desmos here. So 24 squared is 576 plus b squared equals, okay, now 25 squared is 625. All right, so you're solving this equation. So you got to isolate the variable. You have to isolate b squared. So that means you need to do the opposite of a positive 576. So you're going to subtract a 576 on both sides of the equal sign. Now you're doing this because you want to isolate the variable because you're solving this equation. So 625 minus 576 is 49. Okay, and these cancel each other out. Now, I'm not done yet. A common mistake here is that people would say that the side length of this right triangle is 49, but it's not, because you need to do the inverse operation of squaring something. So the inverse operation of squaring something is taking the square root. So don't forget to take the square root of both sides. That's the biggest mistake that I see students make. That students are going to stop right here and say, oh, b is 49. No, b squared is 49. So you got to take the square root of both sides. These cancel each other out. B and the square root of 49 is 7. So the side length in number 3, this leg has a measurement of 7. Okay, so here we go. We're going to move on. Problem number 4, check your notes to check your work. Problem number 5, some fractions, but it's doable. You should check your notes. Problem number 6, I'll go over problem number 6, okay? Because it's not too bad, I don't think. So here we go. I'll go over it. Number 6. Now, what's pretty cool about these problems is that they already label one of my side lengths as either A or B, so you kind of don't have to think about it because the problem already labeled it for me. But always approach it as, where's the right angle? Right here. And what's adjacent to it? B and point 12. So these are your legs. And then what's across from it is your hypotenuse. So this is C. If this is B, then that means this is A. Okay, so I'm going to use the Pythagorean theorem to find the missing side length. I'm going to find the measurement of this leg. Here we go. A squared plus B squared equals C squared. So A is 0.12, so 0.12 squared plus B squared, which is unknown, I don't know what that is, equals C squared, and C is 0.2, so 0.2 squared. So I can use my calculator to do some of these calculations for me. 0.12 squared is 0.0144 plus B squared equals, all right, what is 0.2 squared? I'm going to use my calculator to figure that out. No shame in using a calculator because it's a tool that it's available. Is 0.04. So from there, I need to isolate the variable. So I'm going to get rid of this 0.0144. So I'm going to subtract 0.0144 on both sides of the equal sign. So I have B squared equals, all right, so doesn't hurt. I have a calculator. Let's use it. 0.04 minus 0.0144. So I have 0.0256. So, like I said, common mistake. Students are going to stop and say, oh, the measurement of B is 0.0256. It's not. B squared is that. So in order to find the missing side lengths, you need to do the inverse operation of squaring something. So it's the square root, and take the square root of this. So I have B equals, so let's see if I can take the square root of, because I might have to simplify it a different way, but let's check. The square root of 0.0256. Do I? Yep. And the square root of 0.0256 is 0.16. So in your right triangle, with a leg of 0.12 and a hypotenuse of 0.2, that means your other leg, the length, is 0.16. Okay? So, number 7. Keep moving. Here we go. Number 7. Okay, so this is not too bad. So So we're going to find the missing side length. And if you notice, we're going to find the leg because one leg is given and the hypotenuse is given. So this is B and this is C. So let's use the Pythagorean theorem. A squared plus B squared equals C squared. A squared is unknown. I don't know what that is. So A squared plus B squared. Well, B is that. 2 square root of 5 squared. And I'll show you how you're going to multiply that, okay? Equals C squared, which is 4 the square root of 10 squared. Okay, so here we go. A squared plus, now this right here, it's not too bad. I'll show you how to multiply this out. So this right here means that I'm multiplying this by itself. So I'm multiplying 2 square root of 5 times 2 square root of 5. Okay, you see that? 2 square root of 5 squared means you're multiplying what's inside the parentheses twice by itself. Okay. Now, when I multiply radicals meaning square roots, I can multiply the numbers. So anything underneath the square root, I can multiply. So meaning I can multiply this square root of 5 with this square root of 5 because they're underneath the square root. Anything outside the square root, I can multiply together. So that means I'm going to multiply 2 times 2. I can't multiply 2 times the square root of 5 to get square root of 10. That's not possible, okay? You can only multiply like terms, basically whatever's underneath the radical. So let's first start with 2 times 2. What's 2 times 2? 4. Now, here's inside the radical. What's 5 times 5? 25. Okay. And then, well, I'm not done yet. What's the square root of 25? The square root of 25 is 5. And what's 4 times 5? 20. Now, if you don't believe me, I can use my trusty calculator here. I'm going to put this in parentheses. 2 square root of 5, close parentheses, and I'm going to square it. And let's see what happens. I'm going to square it, and that's equal to 20. Okay, so that's how you would approach that. So this right here is equal to 20 equals kind of the same idea over here. So you're multiplying 4 times the square root of 10, 4 square root of 10 squared. You're multiplying that by itself twice. Now remember, you can multiply numbers that are inside the radicals. So I can multiply 10 times 10, but I can't multiply 10 times 4 because this is inside the radical and this is outside of the radical. So you can't do that. So let's do what's outside of the radical first. 4 times 4, which is 16. Now let's do what's inside the radical. 10 times 10, which is 100. And what's the square root of 100? It is indeed 10. And 16 times 10 is 160. Now, if you don't believe me, you can always use your trusty calculator to do that. 4 square root of 10, and then I gotta make sure I square it. And it's 160. Okay, so equals 160. Now I'm going to isolate the variable, subtract 20 on both sides. So I'm not going to show this step because I'm running out of room here. Subtract 20 on both sides, and that is equal to 140. However, I'm not done yet. Remember, common mistake is for students to stop here and say A is 140. What do you have to do? Take the square root. So take the square root of both sides, because the inverse operation of squaring something is taking the square root. And A is equal to square root of 140. Now, I'm still not done yet. I know it's a lot of work, right? I need to simplify this radical. So we learned in the previous lesson how to simplify a radical. So because in the problem, in the directions, it's saying leave your answer in simplest radical form. So I need to see, can I factor out a perfect square? So let's start really small. Our smallest perfect square is 4. So let's see if 4 goes into 140. 140 divided by 4. Yeah, it does work. Okay, awesome. So I'm going to break this down. So square root of 140 is the square root of 4 times the square root of 35. And that would be 2 square root of 35. Now ask yourself, is there another perfect square that goes into 35? Well, let's try it. 35 divided by 4. Nope, doesn't go evenly. What's next? 9. 35 divided by 9. So I'm using perfect squares. I'm trying to figure out, can a perfect square go evenly into this radical? Okay, because I'm trying to factor it out. Does it work? Nope, doesn't go evenly. What's next? 16. Does it go evenly? Nope. And then what's next? 25. Obviously 20. So you get the point. This is simplified. We're done. So the missing side length is 2 square root of 35. Okay? So I helped you on number 7. I'm not going to go over number 8. You should be able to do that, even though I have it highlighted. So problem number 8, you should check the notes. So we're going to move on. So maybe this is where you might want to pause the video, work on these problems, the first 10, because the lessons are going to change slightly. So I would encourage you to pause the video, work on these 10 problems, check the notes, check the key. If you're confused on any of these problems, definitely attend the office hours with Mr. Godaboo or I. But try them out and then come back to the video because we're not done yet. There's still a lot to do, okay? So here we go. So, special property of a right triangle. If you have a right triangle, meaning a triangle with a right angle, then you have this property right here, the most famous property, a squared plus b squared equals c squared. But the opposite is also true, which is called the converse of the Pythagorean theorem, meaning if I give you 3 side lengths, so I give you these 3 side lengths, and you do your calculations, and you notice that if you square one of them, and you add it to the square of another one, and you realize that it's equal to the other squared, then guess what? I gave you 3 measurements that are from a right triangle. So that's the converse of the Pythagorean theorem. So in these problems, basically, is what I'll show you here. So these are 3 side lengths, 61, 11, 60. And you're trying to prove that these 3 side lengths can form a right triangle. And the only way you can prove that is showing that you take a squared plus b squared is equal to c squared. Now, in a right triangle, the hypotenuse is always the biggest side length. So it's always important to identify the hypotenuse. And the hypotenuse is the biggest side length. And the biggest one here out of these 3 side lengths is 61. Okay? So 61 is the largest. So that means these are your legs. And honestly, this could be A, that could be B, or this could be A and that could be B. It doesn't matter, interchangeable. However, it's super important to identify the hypotenuse, and the hypotenuse is the biggest side length. Okay, so here we go. This is C, and like I said, this could be A or B, or you could do A or B. That's up to you. But let's see if it does equal. Okay, so we'll say that this is A and this is B. So A squared, 11 squared, plus B squared, 60 squared, is equal to 61 squared. Let's see if it does work out. Let's see if these 3 side lengths truly do form a right triangle. So 11 squared is 121 plus 60 squared is 3,600. So you can always use your Desmos calculator to help you figure these squares out. Okay, so always use your calculator. Use the tools that are available for you. Equals 61 squared is 3,721. So I'm trying to see if both sides are the same, because if they are, then that means that these three side lengths do form a right triangle. So 3,600 plus 121 is 3,721. So it matches up. This does form a right triangle. These three measurements right here. So if you formed a triangle and I gave you a stick that was 61 inches, a stick that was 11 inches, and a stick that was 60 inches, you formed it to form a triangle, it would form a right triangle. There would be a triangle, and one of the measurements of its angles would be 90 degrees. Okay, so that's how you would approach these problems. So remember, key thing is identifying the hypotenuse, and the hypotenuse is the largest side length. So that's the most important part. So you might need a calculator to figure out which one is your biggest side length here to identify the hypotenuse, and same with number 13, okay? So I'll make sure you check the notes for number 12 and 13, okay? So we're gonna move on. So what I would encourage you to do right now is pause the video and work on 12 and 13. Once you're done, you check the notes, come back, because I'm gonna work on the word problems with you, okay? All right, so hopefully you're back, and I'm gonna help you on 3 of the word problems, okay? Because we're gonna apply the Pythagorean theorem. So what is the length of the diagonal of a rectangle, okay, that has a width of 1 inch and a length of 4 inches? So let's draw a rectangle. Here we go. Here's my rectangle. It's the width of 1 inch and a length of 4 inches. And it's asking me, what is the length of the diagonal? Well, luckily we have we just learned the Pythagorean theorem. We can do this. We can figure this out, because this forms a right triangle. So essentially, what you're doing is you're going to apply the Pythagorean theorem. You have the height of this triangle is 1 inch. The base of it is 4 inches. So really, you're finding the hypotenuse, C. You're going to find the length of the diagonal. Basically, I just took this picture and put it over here. All right, let's find the length of this diagonal. So we'll label this A and B. Doesn't matter. A or B is interchangeable, okay? Those are your legs. So here we go. A squared plus B squared equals C squared. A is 1 squared. B is 4 squared. And then C, that's what I'm finding. So 1 squared is 1 plus 4 squared is 16 equals C squared. And then add these up, 17. Now be careful. The side length, the diagonal is not 17 inches. So be careful. You still have to take the square root. You still haven't solved for C, because this is C squared. So do the inverse operation, square root, and C is equal to, it's asking for the length. So let's actually find, what is the square root of 17? Let's round to the nearest tenth, okay? Did I specify in the Desmos lesson? No, I did not. What to round to. So let's just round to the nearest tenth, okay? So let's take the square root of 17. And it's 4.123, so we're going to round to the nearest tenth right there. So C is 4.1. So that means the diagonal here is 4.1 inches. Okay, 4.1 inches. So here we go, moving on. Number 15. I want to go over each word problem so you feel confident for the homework, okay? So number 15, a square. Okay, so let's draw a square. Here's my square. And it has a diagonal. Okay, we're going to draw the diagonal. Has a diagonal of 2 square root of 2 inches. Okay, I'm going to label that. What is the side length of the square? So what is basically what is the side length of the square? Now, here's the thing. As you know, squares, one important property of a square is that all sides are the same. So that means that this is unknown. We're trying to find the side length. But if this is x, then that also means that this is x because they have the same measurement. So like if this had a side length of 5, because it's a square, that means all sides are 5. Okay? So that means I'm going to find the missing side length of this square. Here's my right triangle. This is A, this is B, and here's my hypotenuse. That's C. Okay, so if you need to see it clearly, here's my right triangle right here. That's what I'm looking at. Okay, so let's use the Pythagorean theorem to find the side length. Okay, a squared plus b squared equals c squared. So this problem, number 15, might help you on number 9. So this one right here, it looks very similar. It's very similar to number 9. Okay, so a squared is x squared plus b squared. That's also x squared equals c squared, which is 2 square root of 2 squared. So I'm going to use my calculator to figure that out because I have my tools. Why not use my tools? 2 square root of 2. Oh, forgot to put the parentheses. Let's put the parentheses. Close the parentheses. And square it. And I get 8. Okay, so I have 8. Now, these are like terms. You're going to combine these two. Now, don't get confused. Some people are going to be the x squared plus x squared is x to the 4th, which is not the case because you might be you're probably getting confused with the product property of exponents. These are like terms, so you have two x squared. So you're just combining them, okay? So I'm solving for x squared. I need to isolate this variable. If you notice, 2 and x squared is separated by multiplication. So the inverse operation of multiplication is division. So I'm going to divide both sides by 2. I have x squared equals 4. Now, I'm a broken record here. I know. That does not mean my side length is 4. I still have to take another step to figure out the side length. So because this says x to the power of 2 equals 4, doesn't mean x is equal 4. So do the inverse operation of squaring something, which is the square root of both sides. They cancel each other out, and the square root of 4 is 2. So that means that the side length of this square is 2 inches. Okay, so moving on. Here we go. We got one more problem. So a baseball diamond is in the shape of a square. Okay, so here's my square. The distance between each of the consecutive bases is 90 feet. What is the distance from home plate to second base? So you're trying to find how far is home to second. And they stated that your baseball diamond is a square. So meaning all sides are the same, 90 feet. So I am trying to find the diagonal. So if you look here, I'm going to just kind of turn this. Here's my right angle. And here is my right triangle right there. So what I'm finding actually is my hypotenuse. So let me draw the right triangle nicely here. So really, I have 90 feet as one of my legs. I have 90 feet as my other leg. And what you're trying to find is a hypotenuse, C. So what I just did was took this triangle and kind of rotated over so it looks a little nicer so I can work with it, okay? So this is A, this is B. Use the Pythagorean theorem. A squared plus B squared equals C squared. A squared is 90 feet, so 90 squared. B is 90, so 90 squared equals C squared. So you can use your calculator, handheld calculator, or you can use your calculator that I supplied on Desmos. That's up to you. 90 squared is 8,100. So 8,100 plus 8,100 equals C squared. So 8,100 plus 8,100 is 162, or sorry, 81,000 plus 81,000 is 16,200. I know, I'm a broken record. That does not mean that the distance from home to second is 16,200 feet. We still have to figure out the distance. So we need to take the square root of both sides. Take the square root because I need to find the side length. So the square root of C squared, they're inverse operations. They cancel each other out. I'm left with C, and I'll type it in here. The square root of 16,200 is, I'm going to round to the nearest tenth. So right here, if you notice, is 2, but I'm going to look at the next one over is 7. So the 7 bumps it up. So this is approximately 127.3 feet. So that means the distance from home to second is 127.3 feet. So for anybody who plays baseball, and if you're a catcher, the distance that a catcher, when they make that throw from home to second on a steal, is about 127 feet. Okay, so hopefully the lesson was easy to follow. Make sure you attend the optional office hours with either Mr. Godaboo or I. Okay, thank you.